currently taking a head count on VHF. I heard VU3 MXC, there is a VU2 UPQ, VU3 OSN Rohit, VU2 SSJ, VU2 ASH, VU2 Tango Foxtrot Golf, and VU2 Tango Foxtrot Foxtrot. Anyone else on VHF, please make your call. This is VU3 YWK. Good morning, Vipul. Signal report is 5 and 9. Thanks for coming on this. Any other station on your VHF, please make your call. This is VU3 YWK. VU3 YWK, this is VU3 OSU, good morning, VU3 Yankee Whiskey Kilo, signal report 5657. But still able to copy you. Thanks for joining. Be on standby. Any other station on the frequency, please make a call. The VU3 YWK.
VU3 YWK, VU2ASH.
Yes, sir.
Okay, take a call. How many are copying me? Take a call.
This is Victory on 3 Yankee Whiskey Kilo. Kaka was on the air a few minutes back. He is going to be on VHF. Just wanted to check with any station which exception was not able to hear copy Kaka. Again, any station who was not able to copy VU2 ASH, please make your call. This is VU3 YWK. This is Victory on 3 Yankee Whiskey Kilo. I'm assuming all the stations are able to copy VU2 ASH. VU2 ASH has a report for you, VU3 YWK.
Okay, Roger. Okay, Roger. It is right on time, Ajay. Very good morning to everybody.
Good morning.
Good morning, all of you. Ajay, I'll just quickly give the mic to you to start our session, and then I'll take over. VU3 YWK, VU2ASH.
Just before that, let me just quickly check with VU2 Tango Foxtrot Golf Anil. If everybody on Zoom are able to listen to Kaka. VU2 Tango Foxtrot Golf, please confirm. This is VU3 Yankee Whiskey Kilo.
Yeah, so VU3 YWK, VU2 TFG here on the so VU3 YWK, VU2 TFG here. Yes, everybody is able to see.
Can you please confirm if everybody on Zoom are able to copy VU2 ASH, VU2 TFG, VU3 YWK?
Anil?
Yeah, so VU3.
Anil? Okay, fine.
Thanks for that. Good morning, everybody. This is Victory from 3 Yankee Whiskey Kilo on Pune Net. This is our technical session today on 145.100 with a standard positive shift on our repeater. Your net controller for the day is Victory from 3 Yankee Whiskey Kilo, handles Ajay, Alpha Juliet Alpha Yankee, and QT is Pune. To interrupt the net, please use break for any priority and emergency traffic. Use contact in case if there is any question to be asked. We will be having VU2 Alpha Sugar Hotel taking a technical session today, and the questions will have to wait. So please jot down questions if you have. Also announce in case if there is any specific requirement. Calls for station with emergency or priority traffic. Stations with emergency, medical or priority traffic, please call now. I take that as a negative. We will start the net and I'll hand it over to VU2 Alpha Sugar Hotel to proceed with the technical session. Over to you, VU2 Alpha Sugar Hotel, VU3 Yankee Whiskey Kilo.
Thank you very much. VU2 Yankee Whiskey Kilo. This is VU2 Alpha Sierra Hotel. Very good morning once again to all of you who are attending the session today. The session was long due as we have many uBitX users here in our club as well as nearby. And they were very much interested to know how this rig works, what are the limitations of this rig, and how we can further upgrade this rig. Before I start, let me give a small brief history of this BITX. When the SSB single sideband signal started in India long time back, that time the only means available were phasing type initially. We started with AM, let me put it very clearly, amplitude modulation. We improved it by using compressed carrier modulation, again AM, which was later called as DSB, double sideband transmission. Something a little improvement in the sense that it consumed less power and gave a lot of intelligibility. Later on, again, since it was a DSB, and while you detect the AM, the amplitude modulated signal in your receiver, only one sideband, either upper or lower, is only detected and then converted to the audio, what is modulated on the signal, and that is what the intelligence was. The second sideband, of course, was a total wastage, of course, but it was using power. Then the SSB came in when the single sideband transmission started, and the first thing where we did was of phasing type. Later on, somewhere around 65, 68, 1965, 68, Bell, Bharat Electronic Limited, Bangalore, he came up with crystal filters. 9 megahertz was a very common crystal filter at that time. And many of them built their transceivers with the crystal filters. Now, what is the difference between basic a phase modulated SSB and a crystal filter SSB? Well, I can put it in a very short way. I won't elaborate on that. A phase modulated SSB or phasing type SSB, what we call, is a combination of LC network and inductance and capacitor network. You know, when the signal goes through a inductance, it shifts the signal, it changes the angle. Same thing happens with the capacitor. What they did was they created a 180-degree opposite signal for a desired sideband, and they tried to cancel it out. But again, since LC network is frequency dependent, so pure phasing type, and since our audio, what we try to speak, what we are speaking, it is not a single frequency. It's a multiple frequency, right? We speak from, say, about what we use in communication is from, say, around 200 hertz to about 3.5 or 4 kilohertz, if you use the female voice as well. So this phasing also didn't succeed very much. A lot of, later on, the crystal filters came. Now the crystal filter is something just like a gate. It is like a gate. You can pass a limited amount of frequency through it, and it stops other frequency passing through it. So they designed the crystal filter where only one single band, one side band could pass through that filter, and the other is rejected. Many circuits, many transceivers were developed with Bell filters. During the same period, our old man Farhan, he was very much busy with developing a suitable setup with common available parts, and he came up with the uBitX design. It's a very novel design. Previously, our receivers and transmitters in a transceiver, we were using two separate sections. The receiver was entirely separate. The transmitter was entirely separate. Later on, people tried to combine the common stages to reduce the part count and reduce the cost, reduce the technicality or of assembling it. As I said, Farhan came up with very good idea of using bidirectional amplifiers. Whereas most of the stages he combined in transmitters and receivers. That way, the part count went down considerably lower. His first uBitX transceiver, which came in the hands of HAMS, was during the HAMS convention at Hyderabad. That time, whoever attended that HAMS convention, they were given a uBitX 40 version, that is 40-meter transceiver using uBitX technology. Many of us, probably you remember, you might have attended that session. Here, from our Pune club also, many members had attended that session. And we were gifted by Farhan the PCB for uBitX 40. Most of us very eagerly started with that. Now this first uBitX 40 it was a basic transceiver using bidirectional amplifiers. And it used for local oscillator, that is the frequency standard on which the stability of the transceiver depends. It was a simple transistorized VFO. Now, most of you very well know that to make a stable VFO which doesn't drift is very difficult, rather difficult. You have to take a lot of precautions. Later on, this thing was modified. This VFO was a critical part of this uBitX 40. But it worked. It did work very nicely. But later on, due to this VFO problem, many went by the same time when this thing was going on. The crystal control synthesized VFOs came into the market. SI570, that was the flagship of Silicon Lab. DDS VFOs were again available that time, and many integrated this SI570 synthesized crystal control, PLL control, VFO for their basic oscillator or frequency determining oscillator. But again, it was a single band version. Many developments were there. It was converted to a dual band version. Here also, we had developed the uBitX 40 with 28 option, that is uBitX 40 and 20 combination with a DDS VFO. Many of that tried successfully. While these trials were going on, the problems which were faced by the HAMS, Farhan came to know about that. And he developed a further, he elaborated his circuit further to the microBitX. That was when one stage in between, which was called minima, which he tried to develop with minimum components. Again, a transceiver with minimum components, but somehow or the other, while developing this minima, he practically involved many synthetic homebrewers all over the world to assist this project rather, at different stations, different places, at different stages. And ultimately, somehow or the other, due to some inherent problems with the minimum, Electron came up with the micro-BTX design. And this micro-BTX design, which is called as uBitX, it was a wonderful invention that time. Micro-BTX that time covered almost all our working bands, right from 80 meters to 10 meters, with SSB, single sideband transmission, upper or lower, with CW transmission. He made several versions of this. As the thing went into the market, people started observing various parameters and they came across several problems also. And then by discussion, these things, different models of this micro-BTX were built, starting from V3, V4, V5, V6, which is now latest available. But the basic concept of the micro-BTX remains same. Just let me give you a simple, probably if you have gone through the block layout of micro-BTX to understand its various stages, you may be able to see it yourself. Yeah, Anil has put up the block diagram of micro-BTX V5 design, V5 version. But this design almost remained the same right from V3 to V4, except minor variations, which I'll enumerate later on. It was that time, normally when you design a transceiver or design a receiver, that time it was a tradition to design the first conversion. This is a superheat design, actually super heterodyne design, where you convert the incoming RF signal to an intermediate frequency signal by injection of suitable local oscillator, and then amplify the intermediate frequency with suitable amplifiers, which gives the gain, also the selectivity to a certain extent, and then pass it through a crystal filter, again do a second conversion and pass it through a crystal filter, which makes a gate, as I told you before, to pass the only one sideband, upper or lower sideband, demodulate, amplify the outcome of the crystal filter, demodulate it by injecting the beat frequency oscillator to convert into a single sideband signal. And this is what the conventional practice was there. But most of them used a down conversion. That means if the signal is suppose coming at 10 megacycle, then they beat it with a VFO of 9 megacycle, so that 1 megacycle, I'm just giving you an example, the difference between the two, that is 10 minus 9, it comes approximately 1 megacycle. This 1 megacycle is known as the RF frequency, intermediate frequency. It is selected through proper filters so that no other products, that is RF plus local VFO, 2 RF or RF plus minus 2 times VFO or harmonics are passed through the mixer, because they are not decided. You are only interested to have the only I frequency coming out of it. So this was the previous practice in designing the first mixer. Most of them in our commercial receivers, if you are well aware of, that time which broadcast receivers or transistors what you are using, they were using the IFS 455 kilohertz. If you, most of you must be knowing that. But there was a big problem. Losing the low RF or low IF. Several transmitting stations were also there during this, that period on the spectrum. Secondly, multiple harmonics or many other differences from the incoming RF and local IF also used to pass through and create a noise. And the signal was not clean, what was coming out. There were a lot of birdies, high power local transmission, broadcast transmission, they normally, they drive it optimally, sometimes they overdrive it, it generates harmonics and it causes birdies in our receiver when you are using a low IF. So he experimented with up conversion. That was a very novel thing. Up conversion means converting the incoming RF to much higher level, which is out of the broadcast band, so that any interference from the broadcast band is not affecting the outcome or the IF in any way, not creating any birdies or interference of some sort. So that was the point. Here in this black diagram, if you can see, which is before you, the incoming RF signal is converted to 45 megahertz IF frequency in first mixer. The 45 megahertz is very high from regular broadcast band, which is 0 to 30 megahertz. So there was very rare chance of getting any interference. So this caused a clean signal at IF. This was followed by bidirectional amplifiers. After the amplifiers, the 45 signal was, megahertz signal was also passed through a very narrow 15 kilohertz with bandwidth filter, so that any other product, if at all comes through, maybe by stray coupling or strong interference, it doesn't pass through this filter. So you get a clean IF. Then it was on a further mix in the second mixer to convert the signal for upper side band and lower side band. The suitable local oscillator signal was fed. The outcome of second mixer was again amplified by bidirectional amplifiers. The resultant signal of second mixer was 12 megahertz. That means the 45 megahertz IF to input to second mixer was mixed with 133 megahertz from local oscillator for USB and 57 megahertz for LSB. So resultant was 12 megahertz. They brought down because it is easier to construct a crystal filter at 12 megahertz. Higher you go, you do have some problems, the bandwidth limitations and all that thing takes place. So 12 megahertz was ideal because, and secondly, these crystals were also easily available. He constructed a crystal filter at 12 megahertz. He started with 4 crystals, then went on to 6 crystals. Now he has got an 8 crystal design, which gives a phenomenal selection capacity of the uBitX receivers. The signal was then passed on to a demodulator, where another local oscillator signal for LSB and USB was mixed to convert the output into a suitable low sideband or upper sideband output, followed by an amplifier and a speaker. Now here again, as you see, many stages are common. This was the fundamental. By the time he was designing this, SI5351, this was the IC, a low priced crystal control, synthesized PLA control IC was available with, which was quite stable, and you gave almost a very constant signal at desired frequency, and it had 3 outputs, 5351. So he designed again a VFO, which he called as Reduino, by using a simple Arduino combination and the 5351 combination and suitable filters and these things to get 3 signals out of this IC. This 5351 can at a time produce 3 output signals, 3 local signals as per your program. So these 3 signals were available, quite stable. So this was a boon to the uBitX. So this is how the block diagram, I think I have explained you the block diagram of the uBitX what you are using right now. The amplifier section or the PA section, where the transmitter section of this block diagram, you can see as they are bidirectional thing, the all stages work reverse way. The microphone input was given to the demodulator, which was acting as a modulator at that time, passed on to SSB filter, again selecting the SSB filter, passed on to the IF amplifier, then to second mixer, again passed on to 45 megahertz pass filter, further amplified by bidirectional amplifiers, passed on to the first mixer, where again it was mixed with 45 and converted to the desired band transmit signal. Again, in between there was a 0 to 30 megahertz low pass filter also, so that the higher products are not passed through. That was fed to suitable driver chain, which increased the level of signal to drive the final amplifiers, which are 510, IRF 510 MOSFETs. This was another breakthrough which he tried. The PA transistors that time were costly. They were costly. If you want to go for regular RF transistors which work in this range, they were costly that time. He used these FETs, MOSFETs, and a very good combination to produce a 10-watt signal. Now that was the basic block diagram. If you have any questions about this, you can ask me in our questions and answer session. Further to this became the standard. People bought the V3, V4, V5, V6 versions of this uBitX. Now let me enumerate a little more about what was the difference in all these different versions. I'll just broadly tell you. The basic difference in V3, V4 was the audio amplifier section. Initially, they had used an IC for audio amplifier, which works very good, but unfortunately, its production was stopped. So they have to convert to some other audio IC, LM386 or something like that. But that didn't give a compatible performance to the old IC for audio amplifier, what they had used for audio amplifier. So they made this change for some period. Later on, again in V5, they found this IC also LM386 not to be that much effective in reducing the distortion, audio distortion, amplification. So they went down to conventional PNP, NPN transistors, push-pull amplifiers. That was done in some stages. All these initial models were through-hole designs. Later on, he came up with SMD designs, surface mount components. He used surface mount components on uBitX design that increased the compactness of the whole transceiver PCB. And again, it reduced the stray coupling between various components. When you use through-hole components, sometimes the lead also, they have a long lead, and sometimes they also cause instability problem, unnecessary coupling. The SMD was the perfect solution. Anil, can you change the, yeah. Now the first, on my left-hand side, the first picture shows the latest V5 PCB of uBitX. Most of the stages, you say, it has got a very clean, neat and clean layout. And this way he could compact the whole system and reduce the unwanted coupling between different stages. And he could accommodate all the stages from single PCB. While initially when we used to design these transceivers, we used to make compartments, shielded compartment from different sections of the transceiver to avoid this interconnection or unwanted coupling. Couple them with coaxial cables and all that, and that used to cause a loss also to the signal. But here he could make everything on a single PCB because he avoided the intermediate or intercoupling between different stages by making it compact, making it double-sided. This was a very good system. Here you can see it is very clear. The different sections of this PCB are well explained on HF signals site. I won't elaborate on that. But mainly I'll say the VFO portion is right at the front. At the bottom, you can see is a vertical plate, which is called Arduino. It has a small Arduino as a microprocessor with SI5351, suitable divisions, suitable filters, and different output for the Arduino, because he was using this Arduino for controlling other items also, which are normally we used to control with the relays or transistors, switching transistors, something. He did the same thing, whole thing with the small Arduino. The whole footprint became very small. On the right-hand side at the bottom, you can see the 8 crystal in line. That was the crystal filter he came up with. As I said, he was using initially started with 4 crystals, then 6 crystals, and later on he came down to 8 crystal with quite phenomenal bandwidth and selection. Adjacent to that is the, on the same side, on the right-hand side, you can see the final amplifier IC, small IC, which they were using initially. Again, the first IC, which he started with V3 version, came into the market, and that proved very good. So he has started using the same IC now from a reliable source, so that the problem with the IC is not more there. Above that, you are seeing the black. These are the switching relays. Black square blocks. They are switching relays which select the low pass filters which are You can see the toroids and the capacitor coupling. They are LC filters. They are selected for specific bands. By using just 4 LPFs, you could cover the band rate from almost 500 kilohertz to 30 megahertz. On the top side, on the left side, you can see the PA section. The PA section includes the driver and the final transistors, which are mounted on the heatsink. Extreme left, just below the PA section, you can see a small block. That is the transmit receive relay, which changes the signal from receiver to transmit. The bidirectional amplifiers are activated here by this relay. Also, it changes the antenna. The bidirectional transistors amplifiers, they work when the supply voltage is there, only then that device amplifier will work. When supply voltage is not there, that amplifier will not work. So using two, you have seen the bidirectional amplifiers. Here, the voltage is switched to provide positive voltage to the amplifiers which are used in the receiver. Similarly, again, positive voltage to the amplifiers which are using when you are using in transmit section. This selection is done by this relay. The output of the board is taken on the right hand side upper corner, just is connected. Now this is the basic, I'm telling you about the basic layout of this. Front side, you have got the dial knob which controls the VFO. Adjacent to that is several jacks, which has a keyer jack. You can connect a CW keyer to it as a headphone jack. We can connect a headphone to it if you want to. At the back side, there is for DC input, a fuse. And he has also in V5, he has come up with a USB connector mounted there. This was not there in V3, V4. In V3, V4, you have to mount this USB connector additionally. This I'll come later on. So these are the basic layout, and with this layout, the performance was quite good. However, due to the common available parts, low costing parts, which were used in this transceiver to make this whole transceiver a low cost project, easily affordable to HAMS, there were several problems. Which could have been solved by using higher costing components, but then this would have increased the total costing of the transceiver. So many people who used it, this transceiver worldwide, they came up with several upgradation of this basic micro-uBitX transceiver circuit. Now I'll talk about this. What are the basic upgradations which are available and which you can use for different versions of the uBitX in the second part. I think I'll take a 1 minute break if you allow me. Ajay, VU3YWK, you can take up. If there are any questions in between, you can just note it down. VU3YWK, VU2ASH.
VU2ASH, thanks a lot, Kaka. That was a very long type of work, so I'm sure you deserve a break and I can have some water in between. Thanks everybody for patiently listening. Let me just quickly check out with Anil. Anil, anybody on Zoom first? Anybody has any questions? VU2 Tango Foxtrot call, VU3 Yankee Whiskey Kilo. I don't see, I'm not sure if Anil was able to listen to that. Anybody on VHF, any questions? Please go ahead. This is VU3 YWK.
Anil, you copying YWK?
I am copying. So I think any of the people at home, if they have question, can you speak up?
DSDR dongle to pose their questions to either you or to Anil, VU3 YWK. VU3 YWK, that's a QSL. That's a QSL. Thanks for that. Thank you, SFG, for making all those markings on the picture so that people will be able to understand it very clearly. Let me just quickly take a feedback. Is there anybody who is facing any challenges in the audio part? Please go ahead. This is VU3 YWK. I take that as a negative. Thanks a lot for the feedback. Let me just check if Anil is able to copy. Anil, I'll pass it on to you. Just check if everybody on Zoom is able to copy clearly and if anyone has got any questions. Victor Uniform 2 Tango Foxtrot Golf, Victor Uniform 3 Yankee Whiskey Kilo. V3 YWK here.
So I can.
Please, you can put a note on the Zoom in the chat window. Anyone has got any questions or queries, they can just type in there and then we can take them separately.
Can you hear me?
There I can see on video. I'm not sure if you also ask any question.
Yeah, can you?
Just put it over to you. I think he is talking. Over to you, Anil. Tango Foxtrot Golf, VU3 Yankee Whiskey Kilo.
I think Suresh has a question. So Suresh, over to you.
Yeah, I'm copying Ashok ji and you very clearly, but the other persons I'm not copying. Lots of echo and very too much of disturbance. But the Ashok ji's copy is perfect. That's over.
Yeah, I think Mohan has a question. So I will just unmute Mohan. Mohan, go ahead if you have a question. Hello.
Yeah, go ahead, Precious. Neil, except you, I can't hear anybody else. We have to Tango Foxtrot. We have to Tango Foxtrot. No, there is a communication going on Zoom, and that's why we are not able to copy that. We'll convey it to you later. Let me just check with Anil. If that is over, then we can ask Kaka to proceed. Anil, if the conversation is over, can we proceed? We have to Tango Foxtrot Golf, VU3 Yankee Whiskey Kilo.
Go ahead, Anil.
VU3 Yankee Whiskey Kilo. Kaka, I think you can proceed. There is no other question on Zoom.
So, Kaka,
Okay.
Alpha Sugar Hotel, VU3 Yankee Whiskey Kilo.
Okay, stand by.
so Kaka,
Anil.
you have to relay my message. Otherwise, there will be echo. So
Okay.
on the Zoom, I have not seen any question.
Stand by. Okay, okay. There is only Anil is having a little problem because when he uses his VHF, he's got echo on Zoom. So that's why he had just conveyed me the message through Zoom that he had only one query from Mohan, which I'll deal with on the later part of this over. Presently, I'm using my base station on Simplex. So I hope copy is still there, as TFF says probably is not copying me. So if you, TFF, are you copying me? VU2 TFF, VU2ASH?
This is affirmative, Kaka. I can copy you. VU2 Tango Foxtrot.
Okay, fine. Okay, fine. Okay, so there was a query from Mohan and I'll reply to it in the question and answer session. So I'll take my session further. As I said, there are several problems which came across with the simple circuit and simple cost-effective transceiver to different versions and different people. Several solutions to it were found out. They were published on net, discussed on the net. Even they had a group for BITX20. where these problems were discussed and suitable solutions were given there. Many of those solutions which were tried out and found successful were later on incorporated by many HAMS in their transceivers at different stages. Let me enumerate those problems which were observed. The first problem, which many in V3, even in V4, they observed, that the audio, what was coming out from the speakers of the transceiver was very low, very low. It does happen sometimes. Although Farhan was trying to test each and every stage, but since he had to procure components from various sources, the quality assurance was a bit low. So sometimes a defective audio amplifier stage or an inefficient low gain stage does produce these sort of things. The audio which was coming out from the transceiver and the receiver portion was comparatively quite low. People came out different solutions to improve this audio quality. Anil, can you put that second slide? No, Ajay sent you the slide. Up, yeah, okay. Now you can see on my right-hand side, the top one. Due to this low audio, only the strong stations you could hear. Although the circuit of uBitX was designed to receive weak signals, still the signal being weak and audio being low, you couldn't copy them. So people tried to make changes to its audio amplifier, which you have to do on the basic PCB. Now, for persons who are having with V3, V4, or V5 even, in mostly V5, it is taken care, but there are still few pieces maybe there where they may find the audio being a little low. If you can increase the audio to sufficient level, provide some low frequency and high frequency filters to its input, you still get a perfectly clean signal out with a higher audio output. So take into view several things, suggestions were given by various hands worldwide. What I tried here is written before you. These modules, audio modules, which give about 3 to 4 watt output on a very low level signal, and is a small compact, assembled on a small compact PCB, and they are readily available online. You could buy them. Just by putting them and feeding them the audio signal, the outcome was quite good, quite surprising. The people who were not hearing the weak signal, now they can very well copy them. So this was the first modification which was done, because doing the modification on PCB itself is a bit difficult for, I should say, for inexperienced hands. Nobody will like to touch the assembly parts and make a change there, make a track change and all that. It's very difficult. Sometimes you may create problems. So this was all additional modifications which were done were additional, so that you don't change the basic circuit, will let it remain as such. So by just adding one amplifier module, which is shown on the right hand side, upper one, it's the 3 watt module. The details are available. I'll send it later on to you. You can put it on our group. These modules are available ready-made at a very low cost. By just adopting this model, giving the input signal according to from your headphone socket or audio socket, or right from your loudspeaker also as a in feed for this amplifier, and providing some filters, a filter capacitor network, where you can cut down the lower portion and cut down the high frequency, so you get an in between clear audio. So this was adopted. This was one of the good addition, and most of you who have low output audio, you can use this sort of things. This is modification. The details will be discussed later on. I'll just today I'll enumerate what are the modifications and upgradations are available. The second modification which was necessary for this transceiver was optimization of power, output power. The problem started by using IRF 510. Now IRF 510, these transistors have got a FT of 30 megahertz. That is, they can operate very safely up to 30 megahertz, but as you increase the frequency, their output goes down. About 30 megahertz, the output is practically nil. So due to this particular problem of the final transistors, some sort of compensation has to be done, so that at least when you are having a QRP, you should put out at least some good amount of RF out. For this, as the basic circuit or BIT is concerned, since these transistors has got FT at lower frequencies, they have got very high gain, and this gain was adjusted by a simple potentiometer at the driver stage. But you could adjust that thing once. You can't adjust that thing for every band. So what person tried was selecting this potentiometer for different bands and pre-adjusting it for optimum output to the driver, so that at least you get a respectable signal out. This used, if you can see on the right hand side, the bottom picture, where there are 4 relays and 5 presets which are there on the top. Now these relays are switched according to band which you are going to use, and the respective potentiometer comes into effect, and that you can preset to get a required amount of drive on the band which you are using. This selection of these relays and the band relay and the potentiometer combination is again controlled by your main Arduino. That was, you don't have an extra switching. The Arduino itself, when you change the band in your transceiver, automatically the relay is also switched for the respective band. This gave a tremendous difference to the VITX. For example, as I said, the IRF 510, they can give more than 15 watt output at 80 meters, but that is the optimum output. The transistor is rated for that much. So normally you can have 10 plus watts output on 80 meters by one setting of potentiometer, but if you can keep the original potentiometer at the same setting, by the time you go to 7, the output will drop down to about 8 watts. When you go to 14, the output will drop down to about 5 watts. On 21, it will drop down to about 4 watts. And at 28, it will drop down to about 2 watts or less. Now, this was something which was abnormal. If you wanted to use this transceiver barefoot, that means without an amplifier or so, at least if you have an output of, say, about 5 watt, it is respectable, your signal can be heard. By using this modification, which optimizes power, drive to the pre-driver according to the band selected, was a click. many of them adopted this, but again, this required a little modification to the internal PCB circuits, but the modification was kept to a very small level while doing this. This PCB which you are seeing, this is made by me and incorporated into my transceiver. Most of these modifications I am telling you, I did first on my transceiver, which I had bought along with the group. And after making sure that it does work nicely, I recommend it to the group. So this is what a second recommendation, which I may give you for optimization of power. Now using this, you can have a flat 10 watt, you can limit, if you are using 80 watts, 80 meters, you can limit the output to 10 watts. If you are using 40 meters, it will push your output to around 10 watts. On 20 meters, it will push your output to around 8 to 9 watts. On 21, it will have a plus 5 watts output. And on 28, your output goes to around 4 watts. Now, this range is possible to increase your output of your uBitX to work as a real QRP station. So this was the second modification, upgradation of this transceiver. Then the third modification, what people came across was the heat sink of the final transistors. Now that was a troublesome point in this design. The heat sink, the built-in heat sink, they get hot. If you use your uBitX transceiver, suppose you are using at 40 meters or 80 meters, it is putting out full 10 watt output. If your antenna is perfectly matched, fine enough, it will be loaded. But if it is not properly matched, the reflected current will cause the transistor to have more current flowing through them. And then these heat sinks, small heat sinks which have been provided, they used to get hot. At one point, your final IRF 510 may blow. And this did happen with several uBitX users, because there one more specific point which Farhan has left in this design was possibility of giving different supply voltage to finals. The rest of the circuit can very nicely work on 12 volts, but the final, the PIRF 510 can work right up to 20 volts, 24 volts. By giving additional higher supply to the final, you can push them to more output. Now this was I don't consider this was a boom, this was a drawback. The drawback in the sense that when you are giving higher voltage, taking out higher output from the PA stage, but if your antenna is not properly matched, you are 100% chances of blowing your finals due to overheat. For newcomers, new HAMS, who are mostly the BTEX or the micro BTEX, was mostly bought by the newcomers with a comparatively lesser experience of transceivers. The experienced HAMS who were there in the field, they bought commercial ones. Anyway, so this was a typical problem with the newcomers. They gave higher voltage, or they tried to load this transceiver to a not improperly matched antenna, and they used to blow this 510 IRF 510 due to the smaller heat sinks which are provided inside. Now that was not acceptable, because these IRF 510, you can replace them, of course, but they are matched. Unless you have got a facility and availability of suitable matched pairs, you are putting unmatched transistors, so there will be different current flowing through these IRF. They are in push-pull. So again, the possibility of one transistor getting overheated, another is not operating at all. This was there. I mean, you are bound to damage your final PA stage, or get a distorted signal, or get unsatisfactory output from your uBitX. This is, of course, To solve this, the best way was to use a suitable heat sink for these transistors. The V3, V4 version, you could, that time, the boxes, the ready-made boxes which are available in the market now, of course, they were not available. So many of them, in fact, in club here, when we got our first uBitX transceivers, we mounted them into aluminum box and mounted them such a way that we could mount these two transistors with insulation in between to the aluminum box itself. The whole aluminum box worked as a heat sink. If it is not possible, you can increase. I mean, this was the necessary modification, and probably this saved many finals. So this is one of the possibility, but with the new boxes, which I've seen, you have to be very precautious in the sense that you operate your transceiver, because they in the backside there is no space available in the new boxes which are coming with the V5 version. With just now Anil showed diagram, there is not much space available behind the heat sinks of these PA transistors to mount a little heavier or heftier heat sink. The alternative to this in V5 is to provide a fan, a cooling fan, which possibly you can mount at the top, blowing air on these heat sinks, so you can have a little more life out of it. This was one necessary modification which was possible if you have your own box, or if you are using the ready-made box, you can increase the life of your PA by mounting an external fan on the top of the box, which blows air on these fins, and you can have a little peace of mind. Well, the next modification which they found, as I say, upgradation of this uBitX transceiver, was having an additional menu push button. Now, what exactly here, the main dial tuning encoder button, which changes the frequency, is used to, when you push it, the uBitX goes into menu version for selection of different sidebands or different parameters. But while doing this, if you do not push it with steady hand, your frequency does change. So this was a critical problem in many these things. And there was the built-in software also has a little problem, because for changing the frequency, you move it fast, it changes fast. If you move it slow, it changes slow. So this was another thing. But when you push that main encoder, main dial button, the frequency used to change, and they have to reset it. Suppose you want to go from LSB to CW or LSB to USB. While going through the menu, you push it. By the time you go to LSB menu, your frequency is changed here, because the dial does move during your pressing. So just a small solution to it. You can Anil, change the picture. Anil, you can, yeah. The left hand top, you can see additional push button, a simple push button. By mounting a simple push button in parallel with your encoder switching terminals, you can change the menu without touching the main dial. So it ensures that your signal remains wherever or whatever your signal setting remains at the same place, irrespective of whatever menu change you are operating. You can close it. And this also many of the upgradation of HAMS did this sort of push button. It is a simple mounting of push button and just wiring it in parallel to the encoder switching push buttons. Now, except where to wire, how it is to be connected, this we can discuss later on. But this is one of the modifications because time will not permit to go in detail. The next upgradation, you can see the center picture. This was when the let me put it like that, when the conditions become bad, just as we experienced last year, still sometimes that SSB signals, you hear very few SSB signals on the band. And for the last few months, practically band was completely dead due to sunspot cycle. But during these time also, the digital signals were very much audible. The digital signal means FT8, PSK31, JT65. These are the new kind of transmission which use low power and cover a long distance. This facility is available now. But here in this uBitX, this facility was not incorporated. So when your SSB signal or voice signal, if you don't hear anybody talking in SSB on the band, you can't talk to him. I mean, how to use your transceiver? Simply, if you monitor the whole band, there's nobody there, maybe a few CW stations. And if you go to FT8 frequency or PSK31 frequency, you hear just some PSK signals on that. But they were there all throughout this year. So persons wanted to use this transceiver on digital modes, which came up and became very popular during last year. Now, to make an adoption to these digital signals, the club took a project of designing a TNC node control for the transceiver. This second picture shows this TNC, which was taken as a project for the club. It has got a simply USB to TTL converter. And from converter, you took out a signal for the PTT. Also, you had a modulation. This was connected to your mic as well as your loudspeaker. The signal and the whole setup was connected to your computer. So receiving the signal from your transceiver and sending the tone control PSK signal to the transceiver to transmit, this was taken care of by the computer. But then you had to have some interconnection between these two, the computer and your transceiver. So this TNC node control was designed for that. By using this, it has got two outputs. One is connected to the microphone input, which has a provision for a PTT as well as your microphone input. And the audio signal from the receiver is taken out from the headphone, and these two connections were provided. And then this whole setup was connected to the USB of your computer. You can open FLDG or WSJT sites and then use them for digital signal transmissions. This possibility was created, and many of them used and tried this during this black period of communication last year. On the later on designs, even V3, V4 didn't have these provisions, although there was a provision on Redino to do this, but this was not incorporated in the design. Later on, when the V5 version came in, this whole thing can be taken care of by the Redino also. It has got a microprocessor built in inside with a micro USB connection inside, and all you have to do was connect a micro USB and take out a regular USB connection female out on your chassis. The right hand side most picture shows a modification done to the transceiver by just connecting one cable to the micro USB and taking out the output on the regular USB female. So you can have a just USB male to male connection and connect it straight away to your computer. By adopting this thing, this was done in V3, V4, but V5 has got built in. By using this, you can control the whole digital operation through this USB control itself. Not only that, with this USB control, you can control your complete transceiver. That means you can change frequencies, you can change bands, you can change modes by using ham radio deluxe consoles or similar consoles, suitably interfacing your transceiver using the interface and properly putting the softwares. You can connect your transceiver straight away to your computer by just one single USB cable, what is presently done with the all new commercial transceivers. Even IC7300 got a simple USB connector at the back. You connect a cable to your computer and your whole computer, your whole transceiver is controllable from here. This was not available at V3, V4, so this modification gave that facility. Now they have incorporated this facility into V5, which is a boon. The last modification, which was mainly intended for the newcomers. See, for newcomers, since they are not very much experienced about the optimum setting of your station, that includes power supply, your transceiver, proper grounding, and your antenna. Now the antenna part is a bit critical. All this line has to be optimally tuned. Since remember you're operating a QRP transceiver, which has got a limited output. If your system is not optimum, even this output will be lost in between and your signal won't reach out or you won't be able to receive properly. And you'll get a frustration. And then probably you'll try to go for 100 water. But even with 100 water, these problems persist. The use or operation of QRP is a joy itself. So to make sure your antenna is properly tuned, properly orientated, you are using a proper coax, your connections are proper, you have to either use a SWR meter, have an analyzer, and make sure that your antenna is properly tuned. When you transmit, you get 1:1 SWR, because higher the SWR, you lose power. When you transmit with 1:2 SWR, your power drops down to 30%. If you are going to 1:3, it will almost drop down to 60 to 70%. So if you are putting about 10 watt and 70% gone, then you will just put out a 3 watt signal. Now 3 watt is very low. Probably the other station may not be able to copy. Except again, when you are transmitting in these conditions, the reflected due to 1:3 SWR current which are coming to your PA, they are causing damage or overheating of your PA. Eventually, if you continue to operate in the same situation, it may blow. Your final PA transistor may blow. In such cases, what they do is, instead of correcting the antenna, the persons try to increase the voltage on the PA, which deteriorates the problem further. This is not the solution, my friends. You have to be sure that your antenna is properly matched. For that, there was no provision in this transceiver, normally which is there now, which is called ALC, automatic level control. Now this ALC system works on the SWR in between transceiver and antenna. Now this is normally incorporated on all commercial transceivers, but it was not here. It is simply one SWR bridge in series with your transceiver antenna output and going to the antenna, you put it that thing, take out the reflected waves, reflected current, convert into voltage, convert that voltage suitable, and control your driver stage or pre-driver stage. When the SWR is higher, it gives a negative voltage to the driver to reduce its gain. When the pre-driver stage gets its gain reduced, it gives less output. That means it cuts down the output of your final transistor when the SWR is higher. That is what automatic level ALC circuit does. Now we are doing experiments on this already. ALC circuit and controls has been designed by me. Even the PCB is completed, but so I will take some trials on that. And that will be another addition to this uBitX transceivers. Alternate to that, but when you adopt this ALC system in uBitX transceivers, you may have to do some circuit modifications. So I'm trying to minimize those modifications. Let me work it out on that. Probably I'll come up with those details very soon. Alternate to this, if you do not want to use an ALC, you have to use an antenna tuner. I mean, the whole idea is your transceiver should see a 50 ohm load on its output to make it happy and run cool. Now, this is what is done by an antenna tuner. You can use a small homebrew antenna tuner, a QRP antenna tuner. If you are not sure of what antenna you are going to use, if you are not sure if you are going to use it for field day, then possibly you may not have time to fully tune your antenna. But if you are using an untuned antenna with your uBitX transceiver, you are creating problems for you. So use of a suitable tuner, this is the next thing, which I'll rather suggest as necessary modification or upgradation of your uBitX. Make a simple antenna tuner. Various designs are available for antenna tuner. In our club, Srinivas VU2ASH has made one very beautiful design. Second design I made with a simple pi antenna tuner that I had shown in the club. These sort of small designs with available components can be made, and then your system runs correctly. If you are not in a position to correct your antenna, at least save your transceiver. That was the idea. Okay, these are the few of the necessary modifications which can improve the performance of your uBitX transceivers. There are many, but more, but yeah, one more which I forgot to tell you is the basic change of software. The basic software which Farhan has provided with the uBitX, it had several operational problems. When this thing came into the international market, many developers developed alternate softwares which can work in better way. One of them was Dr. Ian Lee, KD8 CEC, Kilo Delta 8 Charlie Echo Charlie. He was one of the leading world figure on software development, and he developed certain beautiful softwares which you can install in your Arduino and get much better performance or operational ease in your transceiver. Initially, whatever uBitX transceiver had come to our club, I installed that K8 CEC software by replacing the factory built software, and it works nicely. The main criteria of that thing is the tuning. The software which is provided by Farhan in this, the tuning of changing frequency. When you slowly change, you rotate the dial, it goes into hertz. When you move it a little faster, it goes into kilohertz. Move it a little faster again, it goes to megahertz. So this sometimes created a problem when you are operating that thing on a mobile or something. Just when you are going to change something, that jerk, the frequency used to go heavier. So it was reduced a bit with tunable, adjustable tuning rates. This was provided in K8CC. You can change the tuning rate to your desired thing, either 1 hertz or 10 hertz or 100 hertz or 1 kc, according to you, or just by going into menu. If you want to go faster, you can change the tuning rate to 1 kilohertz and you can go by kilohertz. Even you can go by megahertz if you want to. But if you want to remain on hertz, if you even your dial moves a little, it will change the frequency in hertz, not in kilohertz or megahertz. That was a drawback in this. So the Kate took it. Then he also ganged or switched the bands, HAMS bands. The older versions, when you change the band, you go on rotating dial till you go to their band. That took time. In V5, they have adopted the change of band, certain points of KD8CC, but still the software which is developed by K8CC is quite good. Currently, he has got this software with version 1.061 that is available. And that is one of the good software which you can load on your uBitX. And you can find what difference does it cost to your operation. If you're not satisfied, you can go back to your factory software anytime. So these are the few points which I wanted to add. Now, I give it back to you, Ajay, for any possible questions and answers for this session. VU3 UIWK, VU2ASH.
Thanks a lot, Kaka. That was a nice conversation. Thank you so much. I'll first pass it on to Anil. Anil, in case if there is anybody on Zoom who's got a question, we give the priority to members on Zoom and then we can come to VHF. In the meantime, any SWS monitoring this particular session and has got questions, please reach out to any one of us or on WhatsApp groups and share your questions. Anil, over to you. Waiting on to Tango Foxtrot calls. This is Victor Uniform 3 Yankee Whiskey Kilo.
Anybody on the Zoom has questions? Mohan, I see your hand. You've raised your hand. You want to go and ask questions now? Mohan is
Yeah,
not.
Anil, can you hear me?
I can hear you now, yeah.
Yeah, I have put two questions regarding the muffling of the sound. So I was told that I should adjust the BFO, and which has been also done as per the procedure on HF signal and as well also few of the videos. But the muffling sound is not gone completely. So is there an issue with the mic? And the other one also I have put up is, I have that Nextron display and I have a breakout board as well. So in order to connect the mic and the keyer to the Radino, where is the good point I can intercept that cable on Radino and can make a connection at the back of the chassis for keyer and the microphone.
Okay. VU2MMJ, I heard your questions. This is VU2ASH. Regarding your first question, there is muffling of sound. Now I'd like to know this. I hope, I presume this muffling of sound is coming when you are transmitting, not on receive. Is that Roger?
True.
Okay. Okay. Now the muffling of sound which is coming, if you can break this problem, then 70% of this problem is due to your microphone. The 30% of your problem can be the connecting cables or the internal wiring inside or the internal component layout inside. As I understand, you are using a V3 board. As I understand, a V3 board. first you have to check all the,
No, this is V4. This is the V4.
okay, fine. If it is V4, still then, as I said, the 70% problem is from your microphone, the cables, the socket, and 30% is the internal problem. This problem will have to be analyzed. Now, just make sure you can open your microphone and just check whether microphone module or the condenser module is properly oriented on the microphone opening. Sometimes this module shifts. This module shifts, which is mounted inside the microphone. You can open the microphone and see. This module shifts and goes away from the microphone small hole opening in your microphone, and it goes away from that. At that time, whatever you are speaking, it is getting echoed inside your microphone housing and then passing to your condenser microphone. So this thing has to be first verified that the location of your condenser microphone inside the microphone housing is correct, number one. Number two, there is a connecting capacitor. The output of microphone is connected through a capacitor, and there is a damping capacitor also circuit inside. You have to check and see whether the there is a damping capacitor which reduces the high frequencies in the speech. Sometimes if that is not properly used, it will cut down the highs of your audio which is coming through. Similarly, coupling capacitor also does the same act. If you use a smaller capacitor, it will pass the high frequency, it will cut down the low frequencies. Now this capacitor network, you have to make sure that what they are using is correct, or you may have to experiment with these capacitors so that only the audio which you intend to, or the spectrum which you intend to, that is 300 to 3.5 kc, is passed through the microphone to your microphone amplifier. This may be inside microphone. Then you have to check the connecting cable. They are properly connected. The shield is connected properly. The shield is working properly. It is practically ground with the chassis of your transceiver. It's not open somewhere. It's not picking up RF from somewhere. The shield has to work as a shield. You should not pick up any RF, stray RF from surrounding. That you have to make sure. This connection you have to ensure. Then you have to ensure the connection of your plug, microphone plug also, that it has got that proper shielding and the signal path is correct. If all these three things, this is the 70% of these problems. 30% will be the internal wiring and the circuit which you are using. If there is some faulty components there, because some audio filtering is also done in the microphone amplifier section of your PCB. So there you have to also check, but that will be 30%, 70% will be this. So you'll have to check it. If case you cannot, then possibly you can bring your transceiver sometime at the club I work here. So we can have a thorough check, or you can do it yourself and give me a feedback. VU2ASH.
Roger. First part I checked, there was a real offset of the opening of the enclosure exactly on the microphone portion. So I actually removed the plastic portion on the top of that microphone. So now I know that I am speaking into the microphone portion directly. So that portion I have eliminated. And then I have to actually check with the people. I didn't check with the people correctly. So that's another thing. But some people who received, they said that your audio is coming muffled. And I also asked for where do I get a good microphone to view to POP. He said, first you check with the BFO setting. So whether it is at the correctly tuned. So whether it is 11.99.68 or something. So that has been set at the frequency which I saw at the many of the configuration. So I think, but the shielding portion, I think I will have to take care on the microphone. Okay, we'll see that in the eyeball boss. But the second question I have put up is on the where to get the connections on the breakout board, the cable between the breakout board and the Radino for the keyer as well as the microphone.
Okay. VU2MNJ, VU2ASH. Okay, very fine. Now that's one point. Second point, of course, I should be I should tell you, the microphone, the module has to have some vibration absorbing backup. You can use a sponge piece there so that microphone doesn't vibrate when you speak. Secondly, it's not a good idea to speak very close to microphone, because sometimes your sound does cause, if your microphone rattles or vibrates and touches your surrounding housing, it may create unnecessary noise. So you have to provide, just a bit, you have to provide a suitable spongy background to it. Make sure that thing is there. And of course, the BFO setting is one aspect. Now, what you can do to set your BFO practically is, you actually, as I said, the crystals, which the crystal lattice filter, which Farhan has bought, which the crystals we have bought from market, they do have some variation. So the 11.986 watt, the frequency is not constant. It may have a variation in hertz. It may have variation in hertz. So this particular variation, although you may have set, I have seen many BITX transceivers where this some operated nicely at 9986, some operated 9987, some operated 9990. Now this variation in last hertz portion is possible because he is getting these crystals from market, although they are within 100 hertz. They are supposed to be within 100 hertz, but the 100 hertz is also a sufficiently large space to cause a good audio or a bad audio. So how to do that is connect a dummy load to your transceiver, reduce the volume, and monitor your signal on your station receiver without antenna. If you've got an attenuator, you can switch it on. Try to monitor your signal on your receiver, station receiver, and then try to adjust your BFO for a best possible audio if the problem is from BFO frequency adjustment. I hope you got that. That way, don't forget to use the dummy load. Don't transmit on antenna, otherwise your station receiver will get overloaded. Use a dummy load, shielded dummy load, so that there is very minimum transmission. Don't connect antenna to your receiver. Just switch it on, tune the frequency, speak into the microphone, and see what type of audio you are getting on your station receiver. Adjust the BFO to get a clear audio, and then you can note down those frequencies. It may be different. It may be different than the frequency which he has suggested, because as I said, there is a variation. There is a 100 hertz variation from crystal to crystal. In this, they are selected with 100 hertz variation in this crystal lattice filter. I hope this is one problem you can try. Secondly, as far as your breakout board connection, now this is the first one which has come to us. Its connection details and all these things are not very much publicized. Possibly we can do the solution when you bring it into a eyeball gear, so we can visualize it and give a suggestion there. Right now, offhand, it is not possible. If the design or details are possibly available, would have been available on the net, I could have given you a solution here. But those things are not, except the outer cover and shape and something like that. It will be better if you bring your transceiver at a club eyeball, and possibly we can just study the things and give you the solutions there and there. So I hope I replied to your question. Any other question? Ajay?
Yeah, no, just one more. VU2ASH, I just want to.
Anyway, it is we can hear this on whatever you're saying. We can hear on Zoom anyway for some reason, right? So I see that I'm opening up for if there is a question.
Yeah, he's copying you. He's copying you. My microphone is on, and my station receiver VHF is on. He can copy your audio through Zoom through my microphone. So
Okay.
he has copied that.
So Kaka, I think the question, just hold on. So I think there are no more questions on Zoom. So we will switch on to VHF questions. You can keep your microphone on so that other people can hear.
Okay, fine. Okay, fine. Okay. So as Anil says, there is no more questions on Zoom.
I have a question.
Okay.
Yeah, go ahead, please.
Hello.
Ajay, stand by. Ajay, stand by. There is a question from Suresh.
Yeah, you mentioned through a USB port, the CAT control, etc., is possible for the digital working. Can you elaborate on that slightly?
Oh, sure. Sure. No problem there. Actually, there are various softwares. So if you go to KD8 CEC site, if you can go to KD8 CEC site, he has given it complete details of how you can CAT control your microBitX transceiver to work on this different ham radio deluxe or FLDG or WSJT directly through USB control and with his software. So if you install KD8 version 1.061 version, and then he has given the procedure on his side as well, how you can, what modification, what settings you have to do, and how you can do that on your computer and here, so that just USB you can have through control your transceiver through USB and go to digital conditions also. Is that Roger?
Okay, one more question. You mentioned about TNC and digital control via USB. Can you share some details, hardware details?
Stand by. There is a question. There is a question on Zoom. Suraj is asking a question. Probably since the audio is not Zoom audio is not copyable by you, just stand by. I'll when the questions on Zoom finishes, I'll call questions again on VHF. Just stand by. So can you repeat your question, Suresh?
Yeah, you showed certain modifications like TNC. Yeah, sorry. You mentioned certain modifications in your slides, like TNC and digital control, etc. Now, as far as the audio is concerned, of course, I have used the same audio module, but this TNC and the digital control, the PCBs which you have shown, and also the ALC part, will it be possible for you to share the circuit diagram or the PCB if at all made by you?
Okay. Okay, Suresh, no problem there. In fact, this TNC using USB to TTL converter, this we had taken as a project for our club, and many of HAMS have made that thing. And its diagrams and details are well available. I'll rather suggest Srinivas to post him some details. He, Srinivas, can post you details, or you can just talk to him. He can send those details. In fact, my computer is right now busy with the Zoom, so I won't be able to do that. But Srinivas can send you the circuit diagram, the PCB layout, and how you have to proceed to you. You can give him your email ID, or you can contact him directly, or you can just visit our club and get those details from there. I hope, because I won't be able to shift right now on my computer here, otherwise I would have given it from here. But it's common. It's this TNC has been prepared, about 15, 16 pieces have been prepared here, and they had used it. Is that Roger?
Roger. One more suggestion, not rather a suggestion, it is an input to the earlier person. I believe he is using the cabinet made by Sanjay Singh. Now, I have the same PCB. The last time I came, I had a similar problem. But subsequently, there have been developments. Sanjay Singh has accepted there were a few flaws in his design, including the breakout board. And he managed to send me the entirely new breakout board along with the wire GST connectors and all that. So, plus he has also now prepared a full write-up, including circuit diagrams of each and every part. So if the earlier speaker doesn't have it, he may probably contact Sanjay Singh again, or contact me. I can forward the PDF files. That's it.
Okay, that's very nice of you, Suresh. That's very nice of you, Suresh. MMJ, I hope you copied what Suresh has to say. He has a similar rig, which you have, made by Sanjay Singh. And there was this problem of breakout board, but he has come up with complete circuit diagram and PDF file and a new breakout board, which giving complete details. Either you can contact Sanjay Singh directly and ask him, or you can contact Suresh here. He can send you the PDF file to solve your problem. I hope MMJ, you got solution to your these things. Any other
Yes,
question
I
on
got
Zoom?
it. Yeah, I got it. Thank you.
Any other question on Zoom, Anil?
No, we are not hearing anybody else on Zoom who wants to have a question.
Okay, fine. There is no questions on Zoom. Now, Ajay, I give it to you if there is any question there on VHF.
VU2ASH, VU3 Yankee Whiskey Kilo. Thank you so much, Tata. Anybody having any doubts or questions on VHF, please go ahead. VU3 okay. VU3 okay. Mr. Suresh Verma was on Zoom, and hence that question was not audible to us. In the meantime, anyone else would like to ask any specific question, please go ahead. This is VU3 okay. I take that as a negative. Karan, no more questions. Over to you. VU2 Alpha Sugar Hotel, VU3 Yankee Whiskey Kilo.
Okay.